Hello everyone, welcome to our channel. So today we're going to discuss about proofs in discrete mathematics as well as mathematical induction. Okay, so what are the different methods of proofs and what is mathematical induction? So how to solve a problem using mathematical induction? Okay, so theory part and all I will record like this, and whenever there is any problem to be solved, I will solve it on the whiteboard. Okay, so that would be better. Okay, so theory part and all writing on the whiteboard by wasting of time is not correct. So theory part and all I will explain like this, and whenever we able to solve a problem, I will solve it in the whiteboard. And before starting our topic, the students who are watching my channel for the first time, I request you to please subscribe my channel and please share my videos to your friends and well-wishers, and please support my channel in all possible ways. So coming to our topic, proofs. Okay, so a proof is a clear explanation accepted by mathematical community of why something is true. Okay, so if we say that this one is true, then we'll ask how it is true. So what is the proof for that? Okay, so ancient and Babylonian and Egyptian mathematics has no proofs, just examples and methods. So proofs in the way we use them today begin with Greeks and Euclid. Okay, so what are the different methods of proof? So there are different methods of proof as follows. First one is direct method, second one indirect method, third one contradiction method, so fourth one vacuous method, and fifth one method of induction. Okay, so and method of induction is the most important, which we call it as the mathematical induction. Okay, so direct method, indirect method, contradiction method, vacuous method, we already discussed, we already studied this in our intermediate. Okay, so mathematical induction is the one which is most important. We'll discuss it now. Okay, so coming to mathematical induction. So what is mathematical induction? So here we discuss another proof technique such that statement to be proved can be put in the form of P of n. Okay, so let us assume that the statement which we are trying to prove can be put in the form of P of n. That means the n which we are writing there for all n greater than or equal to n0, where n0 is some fixed integer. So if we say n greater than or equal to 5 or n greater than or equal to 6 or n greater than or equal to 10, like that. So n naught is some fixed integer. Okay, so that's that means what we are trying to show in mathematical induction is we are trying to show that P of n is true for all integers where n greater than or equal to n naught. For all these conditions, if it is satisfied, it should be true for all the integers. Okay, so the following results show this can be done. Suppose that P of n0 is true, and if P of k is true for some k greater than or equal to n0, then P of k plus 1 must also be true. Then P of n is true for all n greater than or equal to n0. Okay, so what is the case here? So for example, if we say P of n, so P of n equal to some n plus 1, let us assume. So it should be true for P of 1, that is 1 plus 1, and P of 2, that is 2 plus 2, 2 plus 1, P of 3, 3 plus 1, like that it should be true for every case. Okay, so if we substitute P of k, k plus 1, it should be true for every case. Then we can say that by mathematical induction, it's a proof technique. So that means we are proving somehow. Okay, so P of n naught is true and P of k is true for some k greater than or equal to n naught, then P of k plus 1 must also be true. This result is called principle of mathematical induction. This is the most important topic. Thus, to prove the truth of the statement for all n greater than or equal to n naught, P of n using the principle of mathematical induction, we must begin by providing directly that the first proposition P of n naught is true. Okay, then we should have some basic step of induction. So first we'll say that P of n naught is true, next P of n1 is true, like that up to P of n plus 1 should be true. Okay, so in this way we'll prove. Okay, so thus we must prove that P of k tends to P of k plus 1 is a tautology for any choice of k greater than or equal to n1. Okay, so in short, we solve the following steps. Assume that show that P of 1 is true. Assume P of k is true. prove that P of k plus 1 is true using P of k. Hence, P of n is true for every n. So, if it is true for P of 1, if it is true for P of 2, if it is true for P of 3, so it is true for P of k plus 1. It is also true for P of k. Okay. So, this is the basic introduction about principle of induction. Now, we'll solve all these problems on whiteboard. Okay. So, using principle of mathematical induction. So, in examination, they will ask you like this. Using principle of mathematical induction, prove that 1 plus 2 plus 3 so on up to n equal to n of n plus 1 by 2. So we should show, that means we should prove for every case. Okay. So so let's solve this on whiteboard. So using principle of mathematical induction, prove that 1 plus 2 plus 3 so on up to n equal to n into n plus 1 by 2. So we should solve this using the mathematical induction. So what we said, so for every case it should be true, right? So if we substitute P of 1, so 1 into 1 plus 1 by 2. Okay. So it should be true, right? That means P of 1. So if you take P of 2, it should be true. If you take P of k, it should be true. If you take P of k plus 1, it should be true. So it should be true for every case. So let's take P of 1. So P of 1 equal to, that means here n equal to 1. So in the place of n, we should substitute 1. So 1 into 1 plus 1 by 2. So what do we get? 1 into 1 plus 1 is 2 by 2. So 1 into 2 is 2. So 2 by 2, which is equal to 1. So here we got same. P of 1 equal to 1. So if you take 2, so step 1 is P of 1 is true. Step 2 is we assume that the P of k is true. So 1 plus 2 plus 3 so on up to k equal to k into k plus 1 by 2. So k into k plus 1 by 2. Now assume that we should add k plus 1 on both sides. So add k plus 1 on both sides. Okay, so 1 plus 2 plus 3 so on up to k plus 1 equal to k plus 1, sorry, k into k plus 1 by 2 plus k plus 1. So adding k plus 1 on both sides. Okay, so I'm erasing this, we have no space here. Okay, so now we'll see what we'll get. So we get k plus 1 into k by 2 plus 1, which is nothing but k plus 1 into k plus 2 by 2. So k plus 1 into k plus 2 by 2. Okay. So the last statement may be written as 1 plus 2 plus 3 so on. So k plus 1 equal to k plus 1 into k plus 2 by 2, which means that P of k plus 1 is true. Okay. So first P of 1 is true. Later on we substitute P of k. P of k is also true. Later on we substitute for P of k plus 1. P of k plus 1 is also true. So it is true in all cases. So it is true in all cases. This is called mathematical induction proof. So we prove that 1 plus 2 plus 3 so on n equal to n into n plus 1 by 2. Okay. So finally we get it is true for all the cases. So in this way we will solve the proof of mathematical induction. So in our next video we will solve the different example sets. Okay. So those who are watching my channel for the first time, I request you to please subscribe my channel and please share my videos to your friends. Thank you.